all started with me taking measurements for a piece of pipe to install the magneto. And of course I went to mess with my scrap metal pile again, and apparently not only with it. The pipe fit perfectly by the outer diameter, but not by the inner. The difference with the inner diameter could be leveled with the magneto mounting flange, so I wasn't really upset. Well, just like as always. Then with a smart look on my face, I measured something with my trashed caliper and decided that the magneto shaft won't have a seal, so I machined off a part of the shaft and cut threads at the end with the magneto drive. Then I was doing something, don't even ask what, after which I began making the drive that rotates the magneto. As a result, I get such a thing, and I was on cloud 9 of happiness that I survived after machining it. But don't get too excited, my friend, because a little later, this thing will go to the grinder milling machine for revision. And now I'll say something very important. That chicken cage that gave me metal to make the timing cover, in fact, gave me not 3, but 4 pieces of metal, and the 4th piece, as you might have guessed, will go into business now. First, I cleaned it off some junk, which later, obviously, will go for something else. And I'll make out of this piece the magneto mounting flange. Searching for a template for marking the diameter of the plate, all of a sudden a roll of masking tape came to my hands, which a little later will play another important role. Next, nanotechnological straightening of the chicken plate and cutting off a piece of pipe. Then again, the arena enters the roll of masking tape, which has an outer diameter of the size of the plate and an inner diameter of the size of the pipe, which allowed me to align the units. Then I tacked all the stuff together, welded it, and threw it on the lathe. And to the delight of all turners, I straightened the plate and bored a hole in it on a lathe, instead of drilling a bunch of holes and knocking out the centerpiece with a chisel. That's so sad. Then the magneto drive lost a part of its soul, and the flange received a hole and threads. By the way, the rectangular knob at the end of the magneto shaft is the timing advance unit. Then I shortened the pipe, set this whole pile up and tacked it. Then took off the cover, welded it all, and cut off everything superfluous from the flange. After that, it was time to make the intake manifold, and for this I had to assemble the top end, but in order to assemble it, I had to install the rest of the studs and put gaskets. Putting factory-made gaskets on a homemade engine seems to me a little out of feng shui, so I made homemade gaskets. Then the pistons were installed, and at this moment I was pretty surprised, because the piston with the TCD stamping had the arrow stamped in the opposite direction. You need the arrow not only so the diameters of the valve recesses on the pistons coincide with the size of the valves themselves, but also so the offset of the wrist pin hole in the piston is on the correct side. On this piston, both of the valve recesses and the pin offset were correct, but the arrow was turned to the opposite direction. I can imagine how bad this piston was knocking in the previous owner's engine, so it's not surprising that the skirt of this piston was eventually broken off and it ended up at the junkyard from where I eventually got it. Therefore, be careful when installing pistons, because the presence of an arrow doesn't always mean that it's correct. New copper rings under the head are also not really proper to install, that's why it gets used once. Then I assembled the top end and made flange templates. One of the 3 flanges I was able to make from the remaining piece of the chicken coop, and the other 2 were cut from another scrap metal piece. I tacked these 3 future flanges together and then tacked them to a pipe. And again, to the delight of all machinists, I bored holes in them on a lathe. Bored a hole and faced off each flange in a row by cutting off the tack welds with a grinder milling machine. As a result, we got 3 flanges in which I only have to drill bolt holes and cut threads in one of them. The middle pieces of the cylinder gaskets were perfect for making manifold gaskets. At first I tried to make a manifold out of an exhaust pipe of some 2-stroke bike, but when I realized the whole pointlessness of this situation, I grabbed a thick-walled water pipe and made a manifold out of it. That's it, the manifold's done. Here we can see how the piston became friends with the head. But as you already know, if something hits something, this place simply needs to be ground down, even if it's a piston. Next, I picked a couple of valves and made cutters out of them with which I'll cut new valve recesses on the pistons. And after that, everything was long and pretty boring. In short, you need to put the cutter in a head, preferably not in your head, assemble the top end, and by rotating the cutter, cut new recesses. During this process, the head must be removed and installed a gajillion times in order to control the process. Or, in simple words, to not drill a hole in a piston. And of course, you have to finish everything with a file. One of the heads had the valve guides changed, but for the second head they had to be replaced because the dangling in the old guide's valve cutters definitely wouldn't do any good. Then I set the timing by eyeball so the valves open and close at the proper time, and got busy with the magneto. This magneto works great on any engine that has its strokes every 180 degree of crank spin, but not on 45 degree V-twins. Here the spark to the second cylinder is supplied much later, so the lobe itself had to be modified. And to modify, as well as everything else, I can only by using an angle grinder and a file. After an absolutely idiotic attempt to solder two pieces of brass with tin, I made a new rotor strap from just a brass tube. Then, out of a piece of fluoroplastic, I made a magneto chain tensioner and machined the bronze bushing for the front cylinder camshaft so the chain doesn't run on bare metal. Next, with a 1.5 meter dentist drill bit, I drilled lubrication holes for the shaft and also countersinked small funnels in order to collect the oil. And then happened something that I thought about for half a year from the moment I welded the case around the crankshaft. The doubts were exactly about how to remove the crankshaft out of the birdhouse. The worst case scenario was that I would cut off half of the crankshaft pinion and then would machine a new one that'll let the crankshaft fit into the case. But I also had problems with the bearing, which didn't want to get out of its seat because it simply rusted dead in there. But again, thanks to the grinder milling machine, which ground everything that was possible and impossible, this rusty starling did crawl out of its birdhouse. And right after I got out of there, I became curious to put it back inside, and not at all surprised, I did not succeed. As a result, the crankshaft can be installed into this birdhouse in only one position out of a trillion, and only I know this position. After this, I made the engine mounts, now and not at the very beginning when I should have made them, just because I'm lazy. A little more and my poor junk pile will get mad at me just because I literally dwell on it now, but once again she helped me out by kindly providing fresh scrap metal for the engine stand. And according to the DKWDDWK method, don't know what to do so I do what I know, I slammed together an engine stand on which it'll chill in the near future. When the bracket was ready, I took care of the crankcase and timing case drain plugs, and also made an inspection window for the crank timing marks. After that, I made a couple of gaskets for both the crank and timing covers and for the magneto. Then, as much as I felt bad for this poor rust, I had to clean it off because there was the fine assembly ahead and I even swept tons of grinding dust in the garage for it. Now imagine the level of seriousness in approaching this event. Well, except for the fact that all the parts were washed from abrasive dust in the same puddle of old Soviet stove fuel. And the bearing, which was completely clogged with abrasive and didn't rotate at all, even began to spin. And a final assembly began. During the build process, I disassembled and assembled it in a couple of minutes, but oddly enough, it took me a couple of days to complete the clean assembly. Needless to say that I picked up used piston rings, but on the other hand, during the assembly process, I lubed everything with fresh oil, not waste oil. While the heads weren't installed yet, I made marks in the crankshaft with the pistons at TDC. The flanges, which I welded by eyeball, squeezed out the sealant evenly from all sides, which surprised me so much that I even had a hope that it won't leak oil too much. Then I took care of the head. On one of the heads, at some point I changed the guides and cut the seats, and on the second head, only guides were changed. Accordingly, seats of the second head had to be cut as well. If doing everything wrong, then full throttle, so I also took used valves, just picked up better ones and lapped them up. Then cleaned it all up and assembled it. Yep, with used springs. Even then I knew that the compression ratio would be too high because the piston diameter remained of a nipper, but the stroke increased by 20 millimeters. Not 2 but 20 millimeters, almost 1 inch. So from the very beginning I put 2 copper rings under each head, used ones. At the same time I installed a manifold, although I didn't suspect that I'd disassemble the top end several more times. Then for a pretty long time I was choosing between nipper and gas 53 push rods. Gas 53 push rods require a little more work just because they don't have a centering nipple on the bottom, but they're 9.5 millimeters in diameter. So it's easier to install nipper push rods, they just needed to be shortened, but they're 8 millimeters in diameter. So gas 53 push rods were shortened, and I made nipples on the lower tips by welding them with stainless steel. I'm curious, my friend, have you ever modified pistons with a chisel? Yeah, I've had to. Then I made a simple ratchet in order to rotate the engine with a 3-phase drill. And then the very 3-phase drill enters the scene, which I've used only twice in my entire life. The first time the condenser blew and almost shut my cojones clean off, and the second time it almost ripped my stomach open. And of course, without spark plugs the drill rotated it easily, which isn't surprising. Then I poured the oil in, and yes, I put diesel oil, although I myself don't like when people put diesel oil into gasoline engines. Luckily there's enough filling holes. About how exactly the rockers and valves will be lubricated and about the oil system in general I've explained in the previous video. I didn't install an oil seal on a crankshaft again because I'm lazy, but the bearing is open, so I put a felt stuffing out of a nipper front end in there and was sure that the oil will leak. Okay. I didn't do a cold break-in on the lathe for certain reasons, so I just rotated it with a drill. At this point I was seriously preparing for the first start, even installed spark plug wires. Used ones. In order to be sure in the carburetor, I pulled it from my daily nipper, and at this moment the week-long saga began with fighting too high compression. So high that the 3-phase drill could not rotate the crankshaft 180 degrees, because when pistons approached top dead center, too much pressure was created. I even tried to put the engine on a lathe, but the shaft didn't align with the chuck. Then I tried to attach a pulley from an electric motor to try and pull with a ripcord, but luckily I found a factory PD10 pulley, so I installed it. But after I tore every single rope in the yard in attempts to spin the engine, I took a parachute sling, and even this idea was unsuccessful because when pistons approached TDC, the excess compression simply stopped all the momentum and did not allow the crankshaft to spin normally. At that time I already knew that I'll have to enlarge the combustion chambers to reduce the compression ratio, but because I was lazy I tried to make it rotate with a Kickstarter. But it also didn't give the opportunity to spin the crankshaft normally, kicking my leg back due to excess compression. In the end I finally acknowledged that it won't work out peacefully, so I disassembled the top end, took the pistons out and machined off everything superfluous from them. Also during assembly I removed the compression ring of each piston so part of the compression would dump to the crankcase, but it pretty much didn't do anything and the compression still remained too high. Then I started looking for a use for the teeth on the PD10 pulley. Oddly enough, gears out of a nipper gearbox ideally suited the PD tooth pitch, so I took out a kicker ratchet with a shaft which by a miraculous coincidence caught the hook exactly in the direction I needed, so I began attaching it to the engine stand next to the pulley teeth. Machined the seat, pressed the ratchet shaft into it, and welded the seat to the stand. Unfortunately I didn't film it, but even this way this giant drill could not rotate the crankshaft normally, so the momentum wouldn't get lost when pistons approached TDC. Therefore I made thick 2mm gaskets and put them under the cylinders, thereby increasing the combustion chambers by 2mm each. After that, with a heart-rending howl of the nipper ratchet, the engine began to spin more or less normally, but another problem arose. The magneto removed from the engine was making super strong spark, but installed in the engine it would simply stop producing spark. Till this day I don't really understand what was its problem, but back then I really wanted to start the engine, so I quickly made a regular points ignition out of the magneto with the battery and an external coil. Brought a couple of wires into the magneto, changed the condenser, connected everything, and it worked. And in fact, on May 26, 2020, it started for the first time. Unfortunately, in a fit of a blinding excitement, I didn't set the camera to record, but it started up for a few seconds and it started without a manifold and a carburetor, literally on gasoline that I sprayed with a syringe into the intake port. But the next day, absolutely peaceful, confident that it will start, I calmly made the wires normally, disassembled the rockers, cleaned and lubricated them again, adjusted the valves, removed everything unnecessary on the way of a push rod, put the manifold in a carburetor, and even managed to visit childhood. If you recognize what it is, then well done. And when my father came to help, I poured gasoline, connected the battery, and hear what happened. Go ahead, got it? It was the very first start, without absolutely any carburetor or ignition adjustments. And the ignition I deliberately made very retarded. Obviously, oil just gushed out of the pushrod holes and out of the crank bearing, but at that moment, as to tell the truth, and now I didn't and don't care about that whatsoever. And sure thing, after it warmed up, it easily started up with a Kickstarter. In a fit of just the wildest adrenaline rush, and in general of total mind clouding, I was no longer up to adjust the ignition and the carburetor. In the same video clip, you can see my absolutely gone crazy eyes. I just knew that it will start, but I didn't hope that it would run so smoothly, would idle, even with the very late ignition, would immediately take the throttle, and most importantly, it almost has no vibration so inherent to 45-degree V-twin engines. On a single bowl of gas, working on 2 cylinders, playing with throttle, it ran for 1.5 minutes. After running out of gas, it stalled. And all the time while it was cooling down, I thought that it stalled because something broke down in it. So naturally, I wanted to start it again, but this time to shut it down myself. So I put the rocker covers on, filled the carburetor with gasoline, and... So yeah, after making sure that it was in perfect order, this time I shut it down myself. After that, for a couple of days, I walked around with the eyes of a man who had been blind all of his life, but then in a second gained his sight. Even now, I don't fully understand what's going on and how the heck a complete working V-twin engine appeared in my garage, because all I remember is that I cut something, ground, drilled, welded, and hit everything with a hammer, and as a result, I have a complete working engine in my garage. For a slightly uninitiated person, I'll say that at first glance, it may seem that it shakes a lot, but my friend, you should know that this is absolutely normal for a 45-degree V-twin engine. Here are examples of factory balanced engines. Ignition is very late, which is why sometimes it reluctantly responded to gas, and the carburetor for such a displacement is frankly not big enough. And by the way, the displacement here, with all the modifications of the pistons and other things, is now about 850 cc's or 52 cubic inches. I'll also draw attention to the fact that I don't have a single drawing. Everything was done live from a 3D model created in my head. I didn't measure the compression ratio nor the sizes of combustion chambers by measuring with oil and syringes. I did absolutely no weight equalizing, and by the way, for the entire time of building this thing, I haven't used a micrometer. And in general, for the most part, I aligned everything with the most accurate instrument. Except, of course, of the cylinder base, which I set up with a corner ruler. And hitting the minutiae as crankshaft balancing, I just welded on the flywheels pieces of leaf springs. The rear fork-type connecting rod is welded together from pieces with electrodes. 3 of the 5 timing gears are handmade, the teeth of which are cut with a grinder. The entire engine case is scrap metal. Wherever you look at, I crossed absolutely all the lines and violated absolutely all the rules. And just about everything here screams that it can't be this way. But the fact is, it can. A few words about the longevity. If you remember, for me personally, it doesn't matter at all. What matters to me is that it starts, runs, and drives, so I don't really care about the longevity. But if you're curious, the longevity here can be achieved very easily. Just to make all the rubbing parts from normal materials with proper heat treatment, then to give the case to a CNC machinist so that all surfaces would get straightened, and it will gain the so much desired by everyone and not desired by me longevity. By the way, what I was quite surprised about was the absence of oil leaks at the mating surfaces and at the welding seams. Oil leaked only from the rear bearing. Well, obviously there's no oil seal in there, and it just poured like a fountain from the pushrod holes. And that's it. Behind the scenes stayed a whole bunch of little things which, in a state of excitement, I didn't film. Of course, I'll mention Burt Monroe, who for me has always been, remains, and will always be my idol. And just the thought of what he was doing in his garage every time puts me just in a stupor. It was the cam chest of his Indian that inspired me when building my cam chest, and later part of the cam chest of his Velo Set motorcycle. The weight without the engine stand is approximately 45-50 kilos. By the way, the very first word that popped up in my mind after it started up was the word savage. It may not be the most elegant name, but it describes the essence of this engine very accurately. Also about the time, I began working on it the last spring, the spring of 2019. Then almost all summer I was looking for a lathe and was at work. Also all winter I did absolutely nothing. Therefore, by April 2020, the work time here is around 3 to 4 months of daily work. Huge thanks to my family who supported me big time at every second. Many thanks to Victor just for being you, for doing what you're doing, and inspired by you and your example, I finally realized that one can build an engine in a dusty garage. Also thank you, my friend, for watching, and see you next time.